Let's start with the XenDesktop controller, which is really the brains of a XenDesktop site. It uses a service-oriented architecture, spreading its functionality across a number of .NET-based Windows services which share a common codebase and a common set of patterns. We call this architecture FMA, or Flexcast Management Architecture. There are currently 11 FMA services which go to make up a XenDesktop site. These have been designed to be modular and reusable. An app orchestration site is built around the same core services. We're going to look at 3 of the FMA services today and how they can be used to create a new desktop machine and how to broker a connection. Let's start with machine creation. Machine creation, or provisioning, is the act of creating new virtual machines ready configured for an end user. It's analogous to going to the store, buying a PC, plugging it into your network, joining your domain, and then setting it up with the operating system and applications your end users will need. Of course, in XenDesktop, all of this is done with VMs in a hypervisor. XenDesktop supports several different hypervisor platforms, and the list of supported hypervisors can be extended via adding new plugins. A forthcoming XenDesktop release is adding support for cloud providers via plugins for Citrix Cloud Platform and Amazon Web Services. To start with, an administrator creates a master image using their operating system of choice, installing the Citrix Virtual Desktop Agent, or VDA, and any applications which they want to be baked into the base image. The administrator also chooses how much memory, CPU, GPU, and network interfaces to give to the machine. Once the administrator is happy, she creates a snapshot, which she will then use to create the machines she will provide to the end users. Machines in XenDesktop are grouped into catalogues for easy management, so the first step is to create a new catalogue. This can be done via Studio, the management console for XenDesktop sites. Studio drives the controller services via a public PowerShell SDK. This means that all admin operations can be scripted via the SDK. In fact, Studio allows the PowerShell history to be captured to make creation of new scripts easier. Next, Studio will create machine accounts in Active Directory for all of the machines requested. And for each machine to be created, the Machine Creation Service, or MCS for short, will request a new VM is created from the base image. For each newly created machine, MCS also creates a delta disk to store writes. Remember that at this stage each machine is identical. MCS will need to give each machine a separate identity to tie it to one of the AD identities created earlier. It does this by creating an identity disk, which will be used by the VDA to set its identity early in the boot sequence. So, we've used XenDesktop to create 3 new machines in a few clicks. The process for creating 30,000 new machines is just the same. Once these machines have been created, XenDesktop can treat them independently, taking on a life of their own. All user changes are persisted in a delta disk. Alternatively, in some situations like a classroom environment, it's desirable for user changes to be discarded upon logoff, leaving the machine in a pristine condition next time a user logs on. This can be achieved by deleting the differencing disk upon logoff. Incidentally, XenDesktop also has a multi-tiered layer cake approach to desktop machines, where a user's image is made up from a static base image, a personalised vDisk, a profile, and applications either streamed or hosted. This means that an administrator only needs to maintain a single image, but end users get most of the benefit of a private dedicated image. But that's another video, so let's ignore that for now. We've talked so far about provisioning virtual machines. XenDesktop also supports physical desktops such as blades in the data center, or you can connect to your desktop workstation from remote locations, and we call this Remote PC. But that's a bit off topic, so let's try connecting to a desktop. Imagine an iPad user logs into Receiver. Receiver contacts Storefront services and enumerates all applications and desktops available to that user. The user selects a desktop to launch, and Storefront passes this request on to the broker service. The broker chooses one of the VDAs. If it's off, it asks the hypervisor to power it on. When the VDA has powered on, the broker sends a prepare request. The VDA then starts listening for a connection. The broker then responds back to Storefront Services. Storefront Services hands off the connection information to the receiver, which launches a connection to the VDA. The VDA validates the connection with the broker, and at this stage, the broker checks out a license from the license server. From here on in, the HDX session operates as normal, promoting a rich user experience down to the receiver. The HDX protocol itself is layered, and inside it are virtual channels. CloudBridge, NetScaler Insight, NetScaler Gateway all inspect at different levels to provide acceleration, analysis and security. The administrator can then monitor and manage her XenDesktop site and end-user connections on a day-to-day basis via Director, a web-based management console. We've only scratched the surface of XenDesktop today. For more information and a deeper dive into the XenDesktop architecture, take a look at the XenDesktop 7 blueprint or the specifications available from the on-screen URL. Thanks for watching.